Imagine looking up at the night sky and seeing that shimmering red dot, Mars, appearing so close you could almost touch it. It seems like a short hop, doesn't it? But looks can be very deceiving when it comes to interplanetary travel. So, why does travel to Mars take so long? The primary reason is the vast, dynamic distance between our two planets, coupled with the incredible speeds and precise timing needed to make such a journey safely and efficiently. Typically, a one-way trip to Mars takes anywhere from 6 to 9 months. The core mechanism dictating this long journey lies in celestial mechanics, specifically the orbital dance of Earth and Mars around the Sun. Neither planet stands still. They are constantly moving at different speeds in their own elliptical paths. You cannot simply point a rocket directly at Mars and fire away, because by the time the spacecraft arrived, Mars would no longer be in that spot. Instead, engineers must calculate a trajectory that intercepts Mars at a future point in its orbit. This necessitates waiting for specific launch windows, periods of optimal alignment that occur only about every 26 months, allowing for the most fuel-efficient path, known as a Hohmann transfer orbit. This elliptical trajectory uses the least amount of energy to transfer a spacecraft between two orbits, but it requires patience. Given these celestial mechanics, how do we plan missions to account for this extended travel time? Space agencies dedicate years to designing spacecraft that can withstand the rigors of deep space for months on end, ensuring robust life support systems, radiation shielding, and sufficient supplies for the crew. The careful timing of launch windows means missions are planned many years in advance, sometimes even decades. Every ounce of fuel, every piece of equipment, and every second of travel is meticulously accounted for. This journey is not just a straight shot. It is a meticulously crafted orbital ballet lasting hundreds of days. The roughly 26-month cycle for optimal alignment is known as the synodic period of Mars, highlighting the cyclical nature of these opportunities. While faster, more direct routes are theoretically possible, they would requiring significantly more fuel, which translates to much larger, more expensive, and heavier rockets, making them impractical with current technology. Therefore, the longer, fuel-efficient Hohmann transfer remains the preferred method. Ultimately, the lengthy travel time to Mars is not a bug, but a feature of our current technological capabilities and the fundamental laws of physics governing our solar system. It is a deliberate and optimized choice that maximizes the chances of success and safety for our pioneering missions, ensuring that every kilometer of that incredible journey brings us closer to our next great adventure among the stars.
Join us at Space Tech Insider, where innovation meets the infinite. Discover the future today.